Well, this is exciting. We're talking about the progress that will be done as we go forward with the Genesis mission. But what we're about to talk about is the tools and capabilities that have already been started and are underway and are being built right now. So I'm going to introduce today Brian Spears, who's the Director of AI at Lawrence Livermore National Laboratory and the Technical Director of the Genesis mission. And Brian has been, when Genesis was just a twinkle in some eyes, was already writing down plans and coming up with solutions on how we can make it a reality. And his work is going to be one of the most important pieces of the Genesis' success, the work he's done and the work he will do. So please join me in welcoming Brian Spears to talk about Lux.
Well, good morning. It is my tremendous privilege to be here. It's great to be here with our government leadership, our lab leadership, our partners, and all of our technical team folks that are gathered. With that, I want to say I'm going to take this moment to speak directly to the challenge teams that are here today. So if you're a challenge team, my words are coming straight to you so we can show you what we've done and what we're bringing you. And if you're not on the challenge teams, you get to watch the nerd-to-nerd connection between scientists and the wild. So enjoy the ride as we go forward. So first, for everyone who's gathered here to get the science done, welcome to the team. This is an amazing moment. Together, we are the vanguard. No one else has tried to do this before. The combination of a computing revolution with national interest to build a capability for the nation to advance those challenge problems. And our mission is super clear. We've got to transform the way we do science and engineering in the United States for enduring national advantage. It's just very exciting. It's a tremendous opportunity. I describe it as a once-in-a-few-lifetimes opportunity, and it's an incredibly weighty responsibility as well. So, welcome to the team, new members. Let's get going. To get going, we've already started building a toolbox for you and for us together. We talked a lot, I've heard words about platforms. We have a platform with a capital P here today. That platform does a few things for us. First, it capitalizes on frontier AI that come from all of our partners in US industry. Those capabilities now power AI agents, specialized pieces of software that you can say accomplish a task and have it go get that task done. A new thing that allows you to do a PhD dissertation in a week instead of 4 years. It's the AI agent harness that's powering that. None of that means anything in this room and what we're doing if we can't take all of the specialized expertise from the challenge performers and their use of facilities and the 8 decades of build-out the Department of Energy has done since the Manhattan Project and pull that all together. The data, the facilities, the key experimental capabilities, the high-consequence production facilities. Connections are the next critical piece that we have to put together. All of that has to get wired in. We have to have models, talk to 3D printers, talk to laser facilities. And those are pieces we can put together from the Genesis technical team. But another critical piece is the hub. And what we're asking for you guys to do is to bring your capabilities in and integrate them so that we have all of those facilities, all of the AI in one platform that can execute closed and self-reinforcing loops to bring the flywheel effect we've been hearing about all morning. And that gets integrated in one architecture that federates all of these things. We absolutely cannot do it alone. We have to do it with our partners. And that's part of what the Genesis Mission Consortium brings to us. Lots of resources have been invested, and those are coming online right now. So for example, a few of our key partners, AWS, Microsoft, Google, and OpenAI, are bringing to you, the challenge teams, frontier token streams in the form of ChatGPT and Gemini, cloud compute and storage, some of which you heard about just in the last panel, specialized AI models that you can use to go attack these challenges for the country. Plus, Genesis and the DOE are bringing leading scientific data, AI models, AI agents, tools, the paths to go find new compute you need to get your jobs done. What does it stack up to? More than $150 million of AI resources that are waiting for you. So divide that out, and you thought you were getting your awards to your PIs, but you're also getting hundreds of thousands of dollars of AI capabilities to make you the best equipped AI for science teams that we can possibly make you. So I hope you're excited. It's a super cool capability to use. I've already been using it in the background, and I promise you, it's awesome. So what are we going to do? platform has you in the very center of it, you challenge team performers. And we hope very much that you will use the agentically driven workflows that are made capable by the platform to go solve your portfolio problems and show the nation what those critical science solutions look like. But don't only use the tools that we bring. You absolutely have to bring your specialized tools, your best self, your subject matter expertise, and the things you're going to build to the table to go solve those problems. And then we want you to come back to the Genesis technical team and show us what is working. What is it that only you knew that has to be integrated into the platform to make it successful in this nation scale effort? And we will integrate that into the platform with a capital P and make sure that it's really successful. But that's not the only responsibility that you have. The other one is, as you look at the challenges that we have to attack, and you find that there's a gap, and we don't want 280 different teams to reinvent the same wheel, say back to us that there's an opening that needs to be closed, and then the technical team will work with you and with the partners to build it once in one platform that is closed and self-reinforcing. So this is what we're going to do. It's cool to put in a diagram. It's better to just show you what it looks like in effect. So I'm going to step aside and let you watch a really great demonstration of the work our technical teams have already done, the product of hundreds of folks who I promise you have slept less than anybody did, even those of you who were delayed on flights getting here. So let's watch that, see what it is, and marvel at what the team has done. Well, maybe somebody who's running the show and play the movie now.
Give us just one moment.
So we did integrate the slides with AI. It's not my own mistake. Well, so I will tell you the key pieces of things that you're going to see so that you're prepped. The thing that really matters for us in working with the challenge teams is that those teams have tools on day one. What the team has done in the background is develop a single sign-on capability that means that no matter which national laboratory people come from, no matter which partner institution that we're working with, there's one place that folks can go to do their authentication and get access to the national Genesis resources. Behind that is a really great piece of technology we call the Model Access Gateway. The Model Access Gateway is the place that you can go get frontier tokens from our partners, like AWS serving compute cycles, like Google serving us tokens, like OpenAI serving us tokens. So for all of the folks who across the national laboratories and the partnerships have varying mileage in your access to frontier capability for AI, we've now leveled that playing field for you. Everybody gets access to the same kinds of resources. So on day one, when you go to solve your problems, you've got the best tools you can possibly get. That would have been a great time.
Brian, as soon as we have video, we will let you know.
Okay, that's great. It's unclear exactly what to do. The flight was fantastic. The 3 hours of sleep were an enormous luxury. So, just to trace out for you the trajectory of where we're going, with these, what we consider great but super basic capabilities right now, we're building on top of them an entire host of capabilities already integrated from the investment that the Department of Energy has done. We have over 300 agents and specialized models from the Department of Energy under management in registries of capabilities that teams can find. We have hundreds of thousands of data artifacts together with dozens of data catalogs that all have model cards that make that data discoverable for humans and also discoverable for AI agents. All of that is integrated inside the platform so that if you're a new user and you don't have to be a deep AI expert, what you do is walk into the mission, go to the GEAR website, the Genesis Education Resource page. It will show you, this is where you get your authentication, this is how you get into the gateway, this is how you get your AI resources. Here's a reference card for setting up an agent. Now go tackle what you need to do. And those agents will be able to look into the vast resources that DOE has put together and say, here's the data that you can go discover. Here are the agents that you can go use. And when you discover that there's an agent missing and you need to write something that's deeply specific,
I want to know what you did the website again.
oh, we will send out to, are you a challenge team performer? We will send everyone to this GEAR website, Genesis Education and Resources, for everyone to find. I was really hoping you were raising your hand to say that the movie was ready. So, the platform is growing incredibly fast. This was supposed to be the introduction to the exciting compute that's going to come. But let me just frame it again, because these are sort of the three pieces that we're putting together. A bunch of capabilities that need a place to run. Those have all been put together. Resources, a discovery engine for seeing what they look like, a workbench to deliver them. On the far right, new state-of-the-art computers that you're going to hear about from our partners right now. And then in the center, a community that we're building. So I think what we will actually do is I'm going to invite Stephen Streiffer, Director of Oak Ridge National Laboratory, and then Thomas Zacharia, Senior Vice President of AMD, to talk about our compute resources, and then maybe we will see the greatest thriller we're going to see on stage today.
If the technology is easy to build, so as Brian was indicating, one of the things that's crucially important for this to succeed is not just the intellectual capacity that's represented in this room in the United States, and actually indeed around the world, but the hardware that makes this effort possible. And Oak Ridge National Laboratory is one of 5 laboratories in the Department of Energy system, along with Argonne National Laboratory, Lawrence Berkeley National Laboratory, Lawrence Livermore National Laboratory, and Los Alamos National Laboratory that made up the hardware side of the computing activity for quite some time. And Oak Ridge National Laboratory in particular is delighted to announce, as many of you are already aware, that we do have 2 new computers that are being added to the mix that will be available to the research teams. The first of these is a machine called Lux, which will be coming online in October. I'll turn it over in a second for Thomas to talk about that. And the second of these will be a machine called Discovery, which will be the next leadership class computing machine that will replace the existing machine Frontier at Oak Ridge National Laboratory. These machines represent the extension of the very productive and long-running partnership that we've had both with Advanced Micro Devices, AMD. I can never get away from the old name, I apologize, Thomas. And the integrator HPE, we're bringing together the national laboratory system, the chip providers, and the integrators. Has really been absolutely essential for us to deploy the machinery that's necessary to power the scientific community. Lux will immediately expand our capability as part of the American Science Cloud to be able to do exactly the work that this room is speaking of. Discovery will be the next step beyond that, which will start to really push the forefront in not only AI, but also high-performance computing and integration of quantum accelerators into the architecture. And we really look forward to deploying these machines on behalf of the Department of Energy and supporting the user community. Now with that, let me welcome Thomas Zacharia, the Vice President for AMD, up to say a little bit more about Lux and the deployment there. So please, Thomas.
Well, thank you, Stephen. And it's just as John Surratt said, this is probably the most important day for science and scientific enterprise. For someone who's been part of the National Laboratory enterprise for a long time, I would say that most people who come to work at the National Lab or any research institution, university, they come there because they have a passion for changing the world and their planet. And they come there every day to perform their life's work. Now they're going to do more of it because it gets compressed. 4 years worth of work gets compressed to 1 week is what I'm told. But it's just more than that. What Genesis offers is this federated scientific ecosystem. People come to national labs because there are these unique tools, whether it's high-performance computing, light sources, neutron sources, etc., etc. And now you have all of that available at your fingertips. And the possibilities are really unimaginable. So this is really an exciting day. I just want to take this opportunity to convey Lisa Sue's congratulations to all of you, particularly to Secretary Wright and Undersecretary Gill. This has been a program that has really progressed rapidly, and congratulations to all the awardees. Now, Stephen described the remarkable capability that ORNL is bringing to the Genesis mission through Lux and Discovery. From AMD's perspective, what makes Lux truly significant is that it represents a new model for scientific computing. For decades, Scientific computing has been centered on simulation. AI changes a paradigm. Tomorrow's discoveries will become seamless, combining simulation, data, AI, model training, inference, and autonomous scientific agents into a single workflow. Presumably that's what you're going to show. That's exactly what Lux is designed to enable. Lux is more than a supercomputer. It's an open, AI-native platform that allows researchers to move seamlessly across an entire scientific workflow, from simulation and AI training to inference and agentic AI. Just as importantly, it's built on an open, interoperable, and resilient software foundation that can be deployed in national laboratories, private sector, research environments, or private clouds. Now, I just want to say, oftentimes, we don't recognize the fact that we are building Genesis on a deep and well-founded foundation. So if you just look at the recent decade, Department of Energy started the exascale computing project, which had been a challenge of delivering the physics-scale system for under 20 megawatts. AMD is deeply proud of our partnership with Oak Ridge and Department of Energy in delivering that. And in order to do that, we had to co-design a completely new GPU to achieve that goal. Next came El Capitan. Once again, we co-designed with leaders at Lawrence Livermore National Laboratory to build the El Capitan with an APU, a CPU and GPU in a single die, which was just really amazing. And the Discovery, once again, leaders at Oak Ridge and DOE said, no, we need 64-bit arithmetic, and so we need a balanced GPU. And we designed that GPU specifically with that in mind. And with Lux, we're actually focused on it as a system, overall system. So I just want to say it's really incredible to see this launch of Genesis mission and how we are partnered with all of you. We look forward to seeing your success. But the one thing that I want to say is that we cannot be done without partnership. I already mentioned Oak Ridge National Laboratory. What Secretary Wright made the reference to the fact that we delivered Lux in record time. It didn't happen by accident. It required deep partnership with our partners at HPE, ORNL, DOE. And so we're really proud to make that system available to you. And if you're not able to see the video, you should actually be able to go to live on the booth. You can actually have access to Lux and play around with it live. So thank you very much. Congratulations.
Brian, if you will click back to the movie slide, it should start.
It's like the voice of God.
The Genesis Mission Platform is a single place for the AI services of American science. One board, one identity, and everything the mission is building waiting behind it. It starts with a single sign-on. One federated identity will carry you from national laboratory supercomputers to commercial cloud, from scientific data facilities to the Department of Energy user facilities. Behind that login is the Model Access Gateway, a unified portal for frontier model access. Pick your model, generate a key, and you are working. No separate account for every provider, no waiting on procurement. What used to take you weeks of setup now takes you a couple of minutes. The gateway speaks the same language as the tools you already use. Commercial assistance from our industry partners connects straight through it. Point the tool at the gateway, drop in your key, configure your AI coding agent, and frontier models are working inside your research environment. Then, just ask. Here, we ask for 10 initial electrolyte candidates for a next-generation battery. Seconds later, we have a starting set with the reasoning laid out where we can inspect it. Rapid access to large language models for coding and for scientific investigation on day one. That is a general model doing general work. We can do more than that. So as you build your own AI tools, you connect them to the ecosystem using open protocols like MCP and A2A. A few lines of configuration and your assistant can reach any tool on the platform. Here, we add two of them. The first is a library of agents developed inside the Department of Energy that generates scientific hypotheses and step-by-step plans to test them. The second is MIST, a materials foundation model developed by our academic collaborators at the University of Michigan. Now watch what the assistant does with them. It calls a hypothesis agent to propose electrolyte candidates and to lay out how each one should be evaluated. It hands those candidates to MIST, which scores their properties. It brings the scores back, then writes the summary, the figures, and the report. These pieces work together because they sit on the same platform and speak the same protocol. The result is a complex scientific workflow that's greater than the sum of its parts. That is the whole idea. Every tool a laboratory or a university brings to the platform unlocks the scientific power of the national labs and of American academia for everyone else on it. The tools are not only models. With simulation agents and MCP tools developed inside the DOE, the platform doesn't just reason about science, it runs it. Here, an agent takes on inertial confinement fusion, dispatching a full suite of simulations across leadership class systems. The runs land, and with one request, the agent reads its own results, writes a plan for the analysis, rendering the figures that make the physics legible. Writing the code to automate the processing, and turns to the visuals. You ask a question, you get a campaign. And the tools can reach past the machine room. With DOE developed MCP tools for robotics operation, the same assistant drives instruments in an automated laboratory. Here, it moves a sample and runs the test. A hypothesis that started as a line of text ends as a measurement on a bench. Take it further still, and you see what the platform makes possible. The Discovery Engine, where you describe the science you need, and intelligent agents find the data, the models, the instruments, and the compute. Then compose the entire campaign. Every action verified, every result traced, and flowing back into a living body of scientific knowledge that is ready for the next researcher and the next agent. This is not a distant vision. The platform is beginning to accept users. The tools are landing, and the door is open to researchers, to universities, to industry, and to our partner agencies across the federal government. Your missions, your data, and your science belong here too. Bring them. The mission has begun. Genesis Mission Platform, built together, discovering faster.
So again, huge thank you to the folks who are making that happen in the background for the technical teams. Huge call to action for the challenge teams who are here to go use that, put it through its paces. It's not perfect, it is amazing, we will make it better, and thanks to everybody.